Hi everyone, today we're going to study permutations. Let us define permutations. A permutation of a set of elements is an ordered arrangement where each element is used once. To illustrate, given the letters A, B, C, how many permutations are there taken two at a time? Let us list the different permutations, and these are AB, BA, AC, CA, BC, and CB. We can see here that there are 6 permutations. Let us study formula for permutations. The first is the formula for the number of permutations of n objects taken r at a time. And this is the formula. And for the symbol, we're going to use this n, capital P, r. And this is equal to the fraction where the numerator is n factorial over the denominator, the quantity n minus r, and factorial. By the way, n factorial is simplified into n times the quantity n minus 1 times the quantity n minus 2 times the numbers of this pattern until it reaches 3 times 2 times 1. For example, if we have 4 factorial, we have here 4 times 3 times 2 times 1. And this is simplified into 24. By the way, by definition, 0 factorial equals 1. Letter B, the number of permutations of n objects taken all at a time. This is now our formula n p n, which is equal to n factorial. Let us see some examples. Compute the following. Letter A, permutation of 6 items taken 3 at a time. Letter B, permutation of 7 items taken 2 at a time. Let us write our formula here, and let us first solve for letter A. The 6p3 equals, the numerator is 6 factorial over the denominator 6 minus 3, then factorial. Let us first simplify the denominator. So 6 minus 3 will be 3. And then let us now simplify the numerator and the denominator. 6 factorial here can be written as 6 times 5 times 4 times 3 factorial. We stopped at 3 factorial because there is a 3 factorial in the denominator where we can cancel the 3 factorials respectively. So we can now simplify 6 times 5 times 4, and this is equal to 120. Let us solve for letter B. So 7p2 is equal to 7 factorial over 7 minus 2 factorial. Let us simplify the denominator. 7 minus 2 will give us 5, and this is factorial. Let us now expand the numerator 7 factorial, and this is equal to 7 times 6 times 5 factorial. Intentionally, we stop at 5 factorial because in the denominator, there is also 5 factorial that we can cancel these 5 factorials respectively. Here we go. So we have now 7 times 6 equals 42. So these are our final answers. Example 2. How many 3-letter word sequences can be formed using the letters A, B, C, D? For our solution, let us note that the value of n equals 4. There are 4 letters here. And for the R equals 3 because we are looking for a 3-letter word sequences. Now let us write our formula. With regard to our problem, the permutation formula is 4p3, which is now equal to 4 factorial over 4 minus 3 factorial. Let us simplify the denominator. 4 minus 3 factorial is 1 factorial. Now let us simplify the factorials respectively. The 4 factorial is 4 times 3 times 2 times 1 over 1 factorial, which is also equal to 1. Simplifying the expression, we have now the answer 24. This is our final answer. Let us have example 3. You have 4 math books and 5 history books to put on a shelf that has 5 slots. In how many ways can the books be shelved if the first 3 slots are filled with math books and the next 2 slots are filled with history books? For our solution, since the math books go in the first 3 slots, we're going to solve for the permutation of 4 taken 3 at a time. And the last 2 slots for history books, we're going to solve for permutation of 5 books taken 2 at a time. And for the computation, we're going to multiply the values for math books times the 2 slots for the history books. Using our formula, we will show here now that this 4p3 equals 4 factorial over 4 minus 3 factorial multiplied by this 5p2. This is equal now to 5 factorial over 5 minus 2 factorial. Let us simplify the respective denominators. This 4 minus 3 will give us 1 factorial, while the 5 minus 2 factorial becomes 3 factorial. Let us simplify the respective factorials. The 4 factorial here becomes 4 times 3 times 2 times 1. This 1 factorial is simply 1 times the 5 factorial is 5 times 4 times 3 factorial over 3 factorial. We will copy it down here. We can see that this 3 factorial and a 3 factorial in the numerator can be cancelled out. Let us now simplify further. The first fraction is now simplified into 24 times the second fraction is equal to 20. And this 24 times 20 will give us 480. It means to say there are 480 ways to arrange first 3 slots for math books and 2 slots for the history books. This is our final answer. Example 4. Find out the number of ways 4 books in a library can be arranged taking all books at a time. This is a problem that is permutation of n items taken all at a time, and this is equal to n factorial. With regard to our problem where n equals 4, we may write now 4p4, which is equal to 4 factorial. And simplifying this, we will write 4 times 3 times 2 times 1. And the product will be 24. This is our final answer. I hope you learned something from this video. See you again next time.